Let's begin with assignment 3, set 2, question number 1. The question says the dissociation energy of hydrogen is these many kilojoule per mole. If hydrogen is exposed to radiation energy of wavelength 253.7 nanometer, what percentage of radiant energy will be converted into kinetic energy? Let's understand the question. In the question, they have given us hydrogen, and this hydrogen, to dissociate this hydrogen, we require 430.53 kilojoule energy for 1 mole of hydrogen. Now, the same hydrogen is exposed to certain radiations, and these radiations are having a wavelength of 253.7 nanometer. So, the question is asking us how much percentage of this radiant energy, the energy that it is receiving from the radiations, how much percentage of that energy will be converted into kinetic energy. तो सबसे पहले तो let us calculate how much energy is it receiving from those radiations. E equal to hc upon lambda. H is 6.626 into 10 to the power minus 34 into 3 into 10 to the power 8 upon wavelength 253.7 into 10 to the power minus 9. These many nanometer. And this energy for 1 mole matlab multiply it by 6.023 into 10 to the power 23 Avogadro number. Okay, now if we solve this, this comes out to be 470.064 kilojoule. So this much energy is the energy to which the hydrogen is getting exposed to, and dissociation energy is 430.53. So what is the extra energy that we are supplying to it? That extra energy will be converted into the kinetic energy. So extra energy will be equal to 470.64 minus 430.53. इसको सॉल्व करिए. 064 था ये. This comes out to be 4 3 हो जाएगा 5 39.534. Okay, and what will be the percentage? That is 39.534. This much has been converted into kinetic energy upon. Let's take up question number 2. It says oxygen undergoes photochemical dissociation into one normal oxygen atom and one oxygen atom 967 electron volt more energetic than normal. Okay, so first understand only this much. What is it saying? That dissociation of O2 is taking place. O2 is dissociating into O plus O, and one O is the normal oxygen. The other one is 1.967 electron volt more energetic than this one. Correct? So let's read further. The dissociation of O2 into two normal atoms of oxygen requires these many kilojoules. Okay. Now, if this would not have been the case, this is case 1. अगर केस दूसरा होता कि डायरेक्टली O2 जो है वो O प्लस O में डिसोसिएट होता और दोनों ही नॉर्मल ऑक्सीजन एटम्स होते, तो इस केस में जो एनर्जी रिक्वायर्ड होती दैट वाज 498 किलोजूल per mole. What is the maximum wavelength effective for photochemical dissociation of O2? Okay. तो सबसे पहले तो हमें ये पता होना चाहिए कि जब हमने केस 1 में जिसके बारे में हमको कैलकुलेट करना है, इस केस में हमारे पास टोटल एनर्जी कितनी है, हमने टोटल एनर्जी कितनी रिक्वायर हुई हमको. ओके, तो देखते हैं हाउ टू सॉल्व इट. अगर नॉर्मल डिसोसिएशन होता, दैट इज योर केस 2, तो हमको कितनी एनर्जी चाहिए थी? 498 किलोजूल पर मोल. तो एनर्जी फॉर normal dissociation. That was equal to 498 किलोजूल, यानी इंटू 10 टू द पावर 3 कर लेते हैं, पर मोल अपॉन 1 मोल. 1 मोल इज एवोगैड्रो नंबर, दैट इज 6.023 इंटू 10 टू द पावर 23. तो इसे अगर सॉल्व करेंगे तो ये आता है 8.27 into 10 to the power minus 19 joule. These many joules of energy is required. Okay, this is what we concluded from the second part, that if normal dissociation is taking place, this much energy must have been required. लेकिन normal dissociation तो हुआ नहीं है. एक एटम जो है वो नॉर्मली डिसोसिएट है, एक एटम के पास 1.967 इलेक्ट्रॉन वोल्ट एनर्जी ज्यादा है. तो ये जो ज्यादा एनर्जी है ये कितनी है? E extra. How much is this extra energy? That is, पहले तो इसको ही let's convert it into joules. 1.967. How do we convert it? Electron volt into joule. Multiply it by 1.602 into 10 to the power minus 19. This comes out to be 3.15 into 10 to the power minus 19 जूल. ये एक्स्ट्रा एनर्जी हमको डिसोसिएशन के लिए चाहिए. ओके, तो total energy in this case, how much do we require? What should be the total energy that we require for dissociation in this case? That is your normal energy, जो अभी हमने कैलकुलेट करी, प्लस योर एक्स्ट्रा एनर्जी दैट यू रिक्वायर. दोनों को ऐड करें तो E की वैल्यू क्या आएगी? E will come out to be, just add them directly, this becomes 1.142 into 10 to the power minus 18 joule. These many joules of energy will be required. Okay, so the question was asking us find the maximum wavelength. Okay, और ये हमको पता है is equal to hc upon lambda. So can we find lambda from here? That will be equal to 6.023, sorry, 6.626 into 10 to the power minus 34 into 3 into 10 to the power 8 upon the energy, that is 1.142 into 10 to the power minus 18. Solve for it. You should get the value of lambda as 1740 Armstrong. These many Armstrong. Let's take up question number 3. It says a certain laser transition emits 6.37 into 10 to the power 15 quanta per second per square meter. Okay, and we have to find the power output in joule per square per meter per second, given that lambda of these radiations is 632.8 nanometer. तो क्वेश्चन क्या कह रहा है समझो से. ये कोई अगर आपके पास में प्लेट है और इसके ऊपर कुछ लेजर ट्रांजिशन हो रहे हैं या कुछ फोटॉन्स जो हैं इसके ऊपर रेडिएट हो रहे हैं, तो कितनी पावर जो है वो, हाउ मच पावर आउटपुट विल यू रिसीव. ओके, तो इसके लिए यू नीड टू नो that for one photon how much energy is required. So let's calculate that first. Energy of one photon will be equal to hc upon lambda. हम डायरेक्टली वैल्यू ले लेते हैं hc की 1.988 into 10 to the power minus 25 upon lambda is 632.8 into 10 to the power minus 9. अगर हम इसे सॉल्व करें तो ये आता है 3.14 into 10 to the power minus 19 जूल. So for one photon, we are requiring these many joules of energy. And the question is asking us to find out for these many quanta, 6.37 into 10 to the power 15 quanta. तो क्या हो जाएगी power output? That is 6.37 into 10 to the power 15 into 3.14 into 10 to the power minus 19. ये क्या था हमारा? These many joule. Let's write the units also. Wait. This was 6.37 into 10 to the power 15 quanta per second per square meter into 3.14 into 10 to the power minus 19 joule. तो ये total power कितनी हो जाएगी? Multiply both of them. You get it as 2 into 10 to the power 3. These many joule per second per square meter. This will be the answer. Question number 4 says, suppose 10 to the power minus 17 joule of light energy is needed by the interior of human eye to see an object. How many photons of green light are needed to generate this minimum amount of energy? Okay, so we need to find this energy, and we know energy is nhc upon lambda. So the question is asking how many photons of green light of wavelength this much. मतलब हमको n की वैल्यू पूछी है. एनर्जी कितनी दी गई है हमको? 10 to the power minus 17 जूल. दिस इज इक्वल टू n इंटू hc की वैल्यू हमको मालूम है 1.988 इंटू 10 to the power minus 25 एंड अपॉन लेमडा दिया है 550 into 10 to the power minus 9. Just find the value of n, which comes out to be 27.66. और इसको approximately 20, क्योंकि number of photons will not be in fraction, it cannot be a decimal number, they have to be whole number, so we can take it as 28. Okay, so 28 photons will be the answer. Let's take up question number 5. It says a certain dye absorbs light of wavelength 4530 angstrom. Assuming that under given conditions 47% of the absorbed energy is re-emitted out as fluorescence. Calculate the ratio of quanta emitted out to the number of quanta absorbed. Okay. So they are asking us for the ratio. और किस चीज का रेशियो? एनर्जी ऑफ क्वांटा एमिटेड अपॉन एनर्जी ऑफ क्वांटा एब्सॉर्ब्ड. करेक्ट? तो लेट्स फाइंड आउट बोथ ऑफ देम. हाउ मच इज इट एब्सॉर्बिंग? एनर्जी ऑफ द क्वांटा दैट इट इज एब्सॉर्बिंग, that will be equal to 6 hc upon lambda. So hc we can take as 1.988 into 10 to the power minus 25 upon lambda is given to us as 4530 into 10 to the power minus 10. इसको solve करें तो this comes out to be 4.83 into 10 to the power minus 19 joule. Now it says 47% of the absorbed energy, 47% of this energy, 4.83 into 10 to the power minus 19 joule, is re-emitted as fluorescence. Okay, let's calculate the energy that has been emitted. So that is 47% of this, means 47 by 100 into 4.83 into 10 to the power minus 19. This comes out to be 2.06 into 10 to the power minus 19 joule. And we have to find the ratio of these two energies. So the ratio will be equal to 0, कितना दे रखा है नहीं सॉरी 2.06 into 10 to the power minus 19 upon 4.83 into 10 to the power minus 19. 10 to the power minus 19 cancelled. This comes out to be 0.47. So this is the ratio. That means for the ratio of the emitted energy to the absorbed energy will be 0.47. या हम ये भी कह सकते हैं कि for every 100 absorbed photons 47 photons will be emitted out. Correct? Question number 6 says a photon of 300 nanometer is absorbed by a gas and then re-emits two photons. One re-emitted photon has wavelength 496 nanometer. Calculate the energy of the other photon re-emitted out. Okay. The question is quite simple. इसमें क्या दे रखा है कि you are having a gas and this gas is exposed to some radiations. So it is absorbing a photon which is having wavelength equal to lambda equal to 300 nanometer absorb कर रहा है और absorb करने के बाद it is emitting out two photons जिसमें से कि एक फोटोन की वेवलेंथ हमको दी हुई है 496 नैनोमीटर और दूसरे फोटोन की वेवलेंथ हमें फाइंड आउट करनी है सॉरी एनर्जी हमको फाइंड आउट करनी है तो लेट्स फर्स्ट फाइंड आउट हाउ मच एनर्जी आर वी प्रोवाइडिंग टू इट ओके तो कितनी एनर्जी इसको दी जा रही है दैट इज एच सी अपॉन लेमडा दैट इज 1.988 into 10 to the power minus 25 upon 300 into 10 to the power minus 9. This much energy you are providing it to. So this comes out to be, इसको solve करें तो 6.626 into 10 to the power minus 19 joule. Okay. Now let's find out the energy of one of the photon. So energy of photon 1 क्या हो जाएगी 1.988 into 10 to the power minus 25 upon 496 into 10 to the power minus 9. अगर इसे सॉल्व करें तो ये आता है 4.01 into 10 to the power minus 19 joule. And the question is asking you to find the energy of the second photon. So that will be equal to the total energy that you have provided minus the energy of photon 1. So this becomes 6.626 into 10 to the power minus 19 minus 4.01 into 10 to the power minus 19. And the answer comes out to be 2.616 into 10 to the power minus 19 joule. So this is the energy of the other photon that is re-emitted out. Let's take up question number 7. The dissociation of iodine is given to us and it is said that it utilizes one photon per iodine molecule dissociated. The maximum ये wavelength होना चाहिए था lambda. The maximum lambda for this is 4995 Armstrong. Calculate the number of moles of iodine dissociated per kilojoule of photon energy. तो step by step चलते हैं. सबसे पहले तो निकालते हैं कि एक फोटोन की एनर्जी क्या होगी, करेक्ट। तो वो हो जाएगी hc अपॉन लेमडा, दैट इज 1.988 इंटू 10⁻⁻25 अपॉन वेवलेंथ दी है हमको 4995 that many Armstrong, so into 10⁻⁻10 मीटर। इसको सॉल्व करें तो ये आ जाएगा हमारा 3.979 into 10⁻⁻19 joule. Okay, so this is the energy of one photon, and the question is asking us to find out number of photons in 1 kilojoule. तो अगर हमको number of photons in 1 kilojoule निकालने हो तो क्या होगा, वो total energy upon energy of one photon, correct. This will give us number of photons, जिसे n से डिनोट करते हैं। तो टोटल एनर्जी दी हुई है हमको 1 किलो जूल। 1 किलो जूल मीन्स 1000 जूल, and upon energy of one photon energy we found out to be 3.979 into 10⁻⁻19 जूल। अगर ये सॉल्व करें तो ये आएगा हमारे पास 2.51 into 10⁻21 इतने photons, right, these many photons, and we have to find number of moles of I2 dissociated per kilojoule of photon energy। तो number of moles कितने हो जाएगा, like 6.023 into 10⁻23, this is 1 mole, these many photon is 1 mole, so 2.51 into 10⁻21 photon will be how many moles, 1 upon 6.023 into 10⁻23 into 2.51 into 10⁻21। ओके, और यहाँ से देखें तो ये बचेगा नीचे 10⁻2। if we divide this gives us approximately 4.175 into 10⁻³ these many moles। this is what we had to find out। दोबारा से देखते हैं एक बार। क्वेश्चन में पूछा गया था कि iodine was dissociating, and when it is dissociating it utilizes 1 photon per iodine molecule dissociated। तो ये 1 photon जो dissociate हो, 1 photon की एनर्जी कितनी होगी। तो सबसे पहले we calculated the energy of 1 photon, that came out to be 3.979 into 10⁻⁻19 joule। Total energy was given to us, total energy was 1 kilojoule। So 1 kilojoule में how many photons will be there, we found out this, or once we got the number of photons, these many photons is equal to how many number of moles, this is what we had to find in this question। Question number 8, it says an atom initially in an energy level with E equal to minus 6.52 electron volt absorbs a photon that has wavelength 860 nanometer. What is the internal energy of the atom after it absorbs the photon? Okay, so here energy of the atom has been given to us as minus 6.52 electron volt, energy of the atom, this is minus 6.52 इलेक्ट्रॉन वोल्ट। क्वेश्चन इलेक्ट्रॉन वोल्ट के टर्म्स में बात कर रहा है तो हम सारा ही डेटा इलेक्ट्रॉन वोल्ट्स के टर्म्स में ले लेते हैं। then it says it absorbs a photon of wavelength these many nanometer. तो इस फोटोन की एनर्जी कितनी होगी जो फोटोन उसने एब्जॉर्ब किया. Energy of photon will be equal to, take the value of h in terms of electron volt, that is 4.135 into 10 to the power minus 15 electron volt into 3 into 10 to the power 8 meter per second upon wavelength दी हुई है हमको 860 into 10 to the power minus 9 meter. Okay, so if we solve this, the energy of photon comes out to be electron volt के terms में ये आता है 1.44 electron volt. Then it was saying that what is the internal energy of the atom after it absorbs the photon. So it has absorbed this photon, then what is its energy? So final energy will be E final will be equal to energy of the atom plus energy of the photon. Energy of atom was minus 6.52 electron volt plus energy of the photon is 1.44 electron volt. दोनों को ऐड किया, we get it as minus 5.08 electron volt. Okay, this is your answer. Then the second part says an atom initially in an energy level with E equal to minus 2.68 electron volt emits a photon that has wavelength 420 nanometer. What is the internal energy after it emits the photon? Okay. Now, in the second part, what is happening? We are having an atom which has energy of the atom is given to us as minus 2.68 electron volt, and it is emitting a photon with wavelength for 20 nanometer. So energy of photon that has been emitted, let's find it out. Again, let's take h in terms of electron volt, 4.135 into 10 to the power minus 15 electron volt, and this into 3 into 10 to the power 8 meter per second upon what is the wavelength given? 420. So 420 nanometer into 10 to the power minus 9. इसको अगर हम solve करें तो this comes out to be 2.95 electron volt. इतनी energy. And it is saying what is the internal energy of the atom after it emits the photon. So after the photon has been emitted, मतलब final energy कितनी होगी इसकी? Final energy will be energy of the atom minus the, because it has emitted the photon, minus energy of the photon. Energy of the atom दे रखी थी हमको minus 2.68 electron volt, or in minus energy of photon we found out to be 2.95 electron volt. तो ये आ जाएगा minus 5.63 electron volt. This will be the answer. Question number 9 says ultraviolet light of wavelength 800 Armstrong and 700 Armstrong when allowed to fall on hydrogen atoms in their ground state is found to liberate electrons with kinetic energy 1.8 electron volt and 4 electron volt respectively. And the question is asking us to find out the value of Planck's constant. So let's move step by step in solving the question. सबसे पहले तो they have given us ultraviolet light of wavelength 800 and 700 Armstrong. So lambda 1 is given to us as 800. Let's convert it into meter into 10 to the power minus 10 meter. Lambda 2 has been given to us as 700 into 10 to the power minus 10 meter. And they are found to liberate kinetic energy. So kinetic energy 1 is given to us as 1.8 electron volt. So 1.8 into 1 electron volt is 1.6 into 10 to the power minus 19. इसको सॉल्व करें तो ये आता है 2.88 into 10 to the power minus 19 joule. And the second kinetic energy has been given to us as 4 electron volts. So 4 into 1.6 into 10 to the power minus 19. That is 6.4 into 10 to the power minus 19 joule. Correct. Now it is asking us find the value of Planck's constant in this case. So let's frame two equations. We know that kinetic energy is equal to the energy that we are providing to the photon uh, minus the threshold energy. That much energy is converted into the kinetic energy, right? So KE1 will be equal to E1 minus W0, and KE2 will be equal to E2 minus W0, and the threshold energy will be the same because in both the cases we are talking about the light which is falling on hydrogen atoms in ground state. Okay, so let's solve these two equations. मान लेते हैं this is equation 1, this is equation 2. Now let me subtract equation 2 minus equation 1 करके देखते हैं. तो क्या हो जाएगा KE2 minus KE1. This will be equal to E2 minus E1, right? So KE2 दिया हुआ है हमको 6.4 into 10 to the power minus 19 और KE1 था 2.88 into 10 to the power minus 19 और ये बराबर हो जाएगा E2 कितना होगा HC upon lambda 2 minus HC upon lambda 1, right? We can take HC common from them. इसको subtract कर लेते हैं तो ये हो जाएगा 6.4 minus 2.88 तो ये आ रहा है 3.52 into 10 to the power minus 19 और ये बराबर होगा HC, let's take it common, 1 upon lambda 2 कितना था 700 into 10 to the power minus 10 minus lambda 1 upon lambda 1, so 1 upon 800 into 10 to the power minus 10. Okay, from here we just have to find out the value of H. थोड़ा substitute करते हैं. So H will be equal to कितना हो जाएगा 3.52 into 10 to the power minus 19 upon C into 1 by 700 into 10 to the power minus 10 minus 1 upon 800 into 10 to the power minus 10. इसे सॉल्व करते हैं. C की भी वैल्यू हमको मालूम है. लेट्स सब्स्टिट्यूट हियर इटसेल्फ. C is 3 into 10 to the power 8 मीटर पर सेकेंड. तो अगर हम इसको पूरे को सॉल्व करें ये क्या आ जाएगा एलसीएम लेके सॉल्व करते एक बार. ये हो जाएगा 3.52 into 10 to the power minus 19 upon 3 into 10 to the power 8. ये 800 into 10 to the power minus 10 minus 700 into 10 to the power minus 10 whole upon 700 into 10 to the power minus 10 into 800 तो 10 टू द पावर -10 ये हो जाएगा। इसे सॉल्व करते हैं तो ये हो जाएगा 3.52 इंटू 10 टू द पावर -19 इंटू 700 इंटू 10 टू द पावर -10 इंटू 800 इंटू 10 टू द पावर -10 और डिनोमिनेटर में आ जाएगा 3 इंटू 10 टू द पावर 8 इंटू subtract these two, this comes out to be 100 into 10 to the power -10। 10 सारे एक साथ हैंडल कर लेते हैं और इसको सॉल्व करते हैं तो दिस कम्स आउट टू बी 19 29 39 39 and this becomes 10 29 then again -8 -29 -8 ओके और ऊपर मल्टीप्लाई करें तो ओके तो ये पूरा आ रहा है सॉल्व करके 6.59 इंटू 10 टू द पावर -39 जूल सेकेंड। So this will be the value of H, Planck's constant. That's it.